when you have simple interest, you have a linear function. And when you have compound interest, you have an exponential function. And we were talking about the possibility of those two meeting, correct? So we said that they meet at t equals 1, which is right here. So what's the moral of this story? The moral of this story is when you invest for a short period of time, which is better? If you're investing for a short period of time, which interest rate would be better? Simple would be better because you're going to get more when you apply this linear function, right? But as soon as time 1 passes, you're better off with compound interest. That's that for those two graphs. So should we write that? Choose compound interest when t is greater than 1 year. So the next one says, draw and describe the amount functions for simple interest, for compound interest, for no interest, and for interest payable only at year end. This is not a big deal. We've done this already. So firstly, simple interest, they want the amount function, AK of t. We said start with k dollars and grow those at a rate A of t equals k times 1 plus IT, or k times 1 plus ST for simple interest. So of course this is linear, and this is for simple interest. For compound interest, obviously it's this exponential curve. I just want to put all 4 of them in the same place. So starting at k, AK of t equals k times 1 plus I to the t power, compound. And then the third one was absolutely no interest. So you start at k and it stays flat. This is no interest. And lastly, you have that step function where you start with k. At time 1, it jumps up because you add the interest at time 1, then it stays flat, then it jumps up. And this is interest payable at year end. You agree, right? We talked about all these 4 scenarios before. This is a step function. This is exponential. Let's go to the next page. A loans B $4,000, and B is to repay A $6,000 in 2 years. What is the corresponding simple interest rate? Could you try this? What is the simple interest rate? 4,000 turns to 6,000 in 2 years. So first of all, what's the formula for the amount function? What's the formula? Simple interest, amount function. Yeah, AK of t equals k 1 plus IT. Okay, so can I set this equal to 6,000? 6,000 equals, I'm beginning with 4,000, 1 plus 2i. I'm solving for I. I equals S, obviously, right? Because it's simple interest. So solve this thing. 3/2 equals 1 plus 2i, and 2i equals 1/2, and therefore I equals 1/4. So I equals S equals 0.25, 1/4, 0.25. Agree? Let's do the next one. How long would you need to invest 5,000 in an account offering 5% simple interest until it grows to 10,000? So this time T is the unknown, right? Would you do it, please? What did you get? 20 years, yeah. 10,000 equals 5,000, 1 plus 0.05 t. Solve for t. 2 equals 1 plus 0.05 t. 1 equals 0.05 t. T equals 1 over 0.05. T equals 20 years. How about the next one? Yeah.
Do we always just assume it's going to be in like years? Or
Yeah, it's in years. So if you get a fraction of a year, that's okay. So if it's 2.1 years, no problem. Okay. Next one. How much money do you need to invest at time 0 in order to have accumulated 6,000 at time 10 if the market is offering simple interest 10%? Same kind of formula. 6,000 equals X. I'm looking for X. 1 plus 0.1 times 10. Same AK of t. So this time I get 6,000 divided by 1.10. I'm sorry, 1 plus 1. Yes, it is. Equals 3,000 equals X. No big deal here, right? Let's go to the next page. Is there any question, guys? Yeah. Sorry. Okay, top of the next page. The monthly simple interest rate is 5%. What is the yearly simple interest rate? Simple interest. So I'm talking about A of t equals 1 plus IT, right? Simple interest. So if the monthly rate is 5%, what is the yearly rate? So what is happening with simple interest? Let's draw this on a number line, okay? start at time 0 with 1. At time 1 month, which is t equals 1 over 12, how much money do you have? It says the monthly rate is 5%, right? So $1.05. 1.1 plus, let's say 0.05 times 1. Yes, you're right. And then at 2 over 12, you have 1 plus 0.05 times 2, and so forth. So at 12 over 12, which is 1 year, you have 1 plus 0.05 times 12. So I annual, which is what I'm looking for, is equal to A of 12 minus A of 0 over A of 0. Remember that I is defined as the total interest earned divided by the initial balance. So the numerator is the interest earned divided by initial balance. We said that the last time. Let's see what page that was on where we said that. We defined I that way. Let's see where that is. It's right here on page 2, right here. I is defined as the interest earned over the initial balance. That's what I'm using. So here I have 1 plus 0.6. That's A of 12 minus 1, A of 0, divided by the initial balance, which is 1. So the 1 and the minus 1 drop, and I get 0.6. So the annual rate is in fact equal to 12 times the monthly rate. And it's equal to 0.6. So A of t annual, for this problem, A of t annual would be 1 plus 12 times 0.05 times t, where this is the annual simple interest rate. Everybody okay with this? This is the crux of the matter right here. So it says here, continuing, unless you have a question, you'll stop me if you have a question, okay? Otherwise, I'm moving forward. Simple interest has a decreasing effective interest rate, I sub n, which converges to 0 as n approaches infinity. So I sub n, meaning I in the nth period, is given by accumulated value at n minus accumulated value at n minus 1 over a n minus 1, where a n is your accumulation function. So let me put this in. I have formulas for this when we're talking about simple interest. So this would be 1 plus I n, I times n, minus 1 plus I times n minus 1 divided by 1 plus I n minus 1. I'm using A of t equals 1 plus IT, right? So these are multiplied, right? 1 plus I times n, that's A sub n, or A of n, minus A of n minus 1 divided by A of n minus 1. So then my job is to clean this up. I get 1 plus in minus 1 minus in plus I divided by 1 plus in minus 1. The 1 and the minus 1 cancel. The in and the minus in cancel. And I'm left with I over 1 plus I times n minus 1. So I claim that this is a decreasing function. This is monotonically decreasing function of n. What is the limit of this as n goes to infinity? Let this go to infinity. If n goes to infinity, n minus 1 goes to infinity also, right? So when your denominator becomes infinite, some little interest rate, 5% or 10%, 0.1 or something like that, divided by infinity, goes to what? 0. So let's write somewhere. Give me 1 minute. I need a piece of paper to write on. Yeah? About the what, honey?
Example for the annual rate.
For the example for the annual rate?
Yeah.
Okay, yeah.
So can I not calculate the annual because you say that the annual rate is about the 12 times the monthly rate. So if I have the monthly rate, so I can times 12 to get the yearly rate.
That's what this is saying. So we just proved that to get the annual rate, simply multiply the monthly rate by 12. That's what we are showing, which is what you would think anyway, right? Mm-hmm. Yeah. Okay, so I would like to show that this is a decreasing function of n. How do we show that this is a monotonically decreasing function of n? How would I show that? Basically, I need to show that I of n is less than I of n minus 1. And then I would have showed that this is decreasing, correct? So I of n is I over 1 plus I n minus 1. And I of n minus 1 would be I over 1 plus I n minus 1 minus 1. So n minus 2 on the bottom. I want to show that I over 1 plus I n minus I is less than I over 1 plus I n minus I minus I. So basically, if I want to show that this is less than this, could I just not show that 1 plus in minus I is always greater than 1 plus in minus 2I? Because if the denominator is bigger, then the fraction is smaller, right? So everything is on the same on both sides, except here I have minus I is greater than minus 2I. Divide by minus 1, I is less than 2I. I is always less than 2I. Right? Divide by I, here. Divide by minus 1. I'm just playing around here. Divide by I. 1 is less than 2, always. Showing that in is always less than n minus 1. So in is a monotonically decreasing function of n. Follow me. Any question? So you remember we were saying in last class that if your money is invested at simple interest, it's better for you to pull out your money and reinvest at the end of the year because your effective interest rate is always decreasing from year to year. So might as well pull out your money and put it in a new account, which is kind of like that example that we were doing when we said, well, is the 250 reinvested in the same amount, or is the 250 put into a new account? Follow me? Because if you put the 250, you know which example I'm talking about, right? The very first page, I believe, of the notes. If you put your 250 into a brand new account, it gets to grow at 8%. But if you leave the 250 there in the same account, it's 100 that gets to grow at simple interest 8%. So you make a lot less money if you leave it in the same account. So it pays to pull out your money and redeposit into a new account. Follow what I'm talking about, right? Okay. All right, what's next? So here we are. Let's call this page 4A. Oh, there is a 4A already. Let's call this page 4, lowercase a. Okay. Take, for example, an investment of $1 at time 0 with simple interest 5%. Each year you gain a nickel in interest because your principal was $1. So for every year, so for year 1, this looks attractive. You gained a nickel on $1 investment. So now you have I at time 1, I1 equals the amount of interest divided by the initial balance. So the interest rate in year 1 is the amount of interest divided by the initial balance. During year 2, you still gain the same nickel in interest because your initial principal was still $1. However, in your bank account, you had $1.05 and you were only gaining interest on $1 of it. So I for year 2 is 5 cents divided by 1.05 because 1.05 is the initial balance for that year. So this value is smaller than 0.05. It's the same point. It's saying nothing new, right? What is 0.05 divided by 1.05? Let's find that interest rate. 0.05 divided by 1.05 is 0.0476. equals I2. So the effective interest rate in year 2 is only 4.76%. It's decreasing. More generally, in year N, you are gaining a nickel of interest on a balance in your bank account of 1 plus 0.05 times N minus 1. Over time, this is not attractive because your bank account keeps going up, but you still keep earning interest only on the $1. If you realize this, you may find it smart to close your account and immediately reopen it to gain the interest I1 in every year, where I1 is 5%. Because if you leave it there, you're going to make less and less money effectively. Follow me? Yes? Let's go to the next page. K loans are $2,400 to be repaid at 1, 2, or 3 years. Show that IN is a monotonically decreasing function of N. So basically, I just want you to find me I1, I2, I3. Can you do those right now, quickly? And then we move on. I1, by the way, is I for 0, 1. And I2 is I for 1, 2. And I3 is I for 2, 3. Would you find me those 3 rates, please? The effective interest rates in those first 3 years. We said before that I on T1, T2 is given by A, K, T2 minus A, K, T1 divided by the initial balance, AKT1. So can you just use this and get me the I1, I2, I3? We will make our point that these are decreasing and we will move on. So for A1, A2, and A3, the amounts at these times, what do we get? What is A1? Right, which is?
2,500
Exactly. And A of 2, 2,640. And A of 3, 2,760. Each time 120 is being added, right? It's simple interest, guys, right? Your money only makes 120 per year, no matter what year, right? Because it's simple interest. So I1 equals, let's plug in here. A of 1, A 2400 of 1, minus A 2400 of 0 over A 2400 of 0, which is 2520 minus 2400 divided by 2400, which gives me 5%. 5% in the first year, no surprise there. In the second year, A 2400 of 2 minus A 2400 of 1 divided by A 2400 of 1. So 2640 minus 2520 over 2520. 0.0476. It's going down. No surprise there either. And lastly, 2760 minus 2640. The numerator remains 120 over 2640, which is equal to 0.0455. So these are decreasing. IN are decreasing as expected. These are the effective interest rates as expected. Yeah?
Could we also use accumulation functions to calculate this?
You can, of course, because capital A K of T is just K times little a of T for simple interest, so certainly no problem. You could have used the accumulation functions and left out the 2400 altogether. Yeah, no problem. Okay. Are we okay? Yeah.
Can you use the formula that you proved before, the I divide 1?
Sure. No problem. I divided by 1 plus I n minus 1. No problem. All right, next page. Now we get to compound interest. We want an accumulation function for which the effective interest rate over a period is independent of the period, i.e., the interest rate is constant throughout. Claim: for all non-negative integers k, ak of t is equal to 1 plus I, not ak of t, a of k is equal to 1 plus I to the k. So look what it's saying. It's saying if I is constant, which is the case for compound interest, then a of t is equal to 1 plus I to the t. That's the claim. Meaning, we saw before that with simple interest, the i's were decreasing and the a was something else. This is saying if your I is to remain constant from year to year, then the accumulation function has to be 1 plus I to the t. We need to prove this by induction. Do you remember your induction? So, first thing to do in induction is the base case. The base case is to show that it's true, show that this is true for t equals 0. So I want to show that a of 0 equals 1 plus I to the 0. And it is. 1 plus I to the 0 is 1. So a of 0 is 1. So it's clear that it is true for t equals 0. Next, assume that the claim, by it I mean the claim, is true for t equals k. So assume that if I is constant, then a of k is equal to 1 plus I to the k. We want to show that a of k plus 1 is equal to 1 plus I to the k plus 1. So I of k plus 1 is equal to I, it's constant, is equal to a of k plus 1 minus a of k over a of k. That's the initial balance. Cross multiply. I'm going like this. A of k is equal to a of k plus 1 minus a of k. So a of k, parentheses, 1 plus I equals a of k plus 1. But a of k was assumed to be 1 plus I to the k. So this one assumed to equal 1 plus I to the k. That was the assumption. So 1 plus I to the k times 1 plus I equals a of k plus 1. So 1 plus I to the k plus 1 equals a of k plus 1. And that is what we wanted to show, and we have showed it. Thus, we prove that if I is a constant, I should say if n is constant, then a of n equals 1 plus I to the n. For integer n. So induction works for integers, right? So since we proved this by induction, it's good for integer values, but it happens to be good for non-integer t also. So actually, a of t equals 1 plus I to the t works for non-integer t as well. What do I mean by that? I mean that if I was looking for a of 10.5 years, this would be equal to a of 10. which is 1 plus I to the 10, times A of 0.5, A of the rest. But what happens in real life is that they use simple interest for the fraction. I don't want to confuse the issue, so what I'm trying to say here is that A of 10.5 is equal to 1 plus I to the 10.5, which is equal to 1 plus I to the 10, 1 plus I to the 0.5. Follow me? So sometimes nothing to do with this, but sometimes simple interest is used for the fraction part, the fraction of the year. So it's not unusual to say that A of 10.5 is equal to A of 10, compounding, and then 1 plus 0.5 I, where this part is simple interest. Means grow it at compound interest up to 10, A of 10, and then simple interest for that fractional part of the year, for that half a year. Follow me? But that is different from this. Any question? You guys have a question for me?
Yeah, so for the fractional part,
Yeah.
simple interest, are they using the original principle or the new principle?
They're using the principle at time 10. So it's saying you reach 10 by doing compound interest, and then for that little piece of the year, they're only going to give you simple interest. Suppose. In that case, it would be like this. Yep. Any questions? Okay, so I guess this is the place to stop today. You can start with your homework. You won't be able to do all of it, but you can do the first 2 or 3 lines of the homework. Okay? I posted the questions to the homework along with the homework, so if you don't own the textbook, you still have the questions that you can print. Have a great weekend, guys. Office hours will start on Monday. Okay?